Okay, so we're back, and in this video, I'm going to use RSI values to predict a buy or a sell situation, situation being 5 days out. From here on out, I won't be using any more models to do price predictions since the prediction values are pretty bad. Two of the programs will be using all numeric values. Again, the result attribute will be buy or sell, and in the other two programs they will be using a nominal or a string value based on where the breakpoint value is. Then between the two programs, one group will just use one RSI value, and then the second group will use two RSI values, kind of like a fast and a slow stochastic. All right, so on to the program. So this is the first of 4 programs we will write to provide us with a buy or sell indicator looking out for 5 days. Current price is first, followed by the RSI, and then the classification attribute result with nominal values of buy or sell. We read in our CSV file, which contains the data. You've seen this all before in the other videos I created, where we add the closing values and the dates to an array list, move the closing array list into a double array for the ta-lib methods. First thing we do is we're going to look ahead 5 days. We will smooth that out using a simple moving average over those 5 days. Again, we realign everything. Everything has to be realigned because ta-lib's methods will align everything at the zero index, and we want everything to be lined up at the same place. Write stuff out to a CSV file and provide a simple header. We're going to do a test RSI intervals from 2 through 25. Set up some of the values that are required by the ta-lib library. And call the RSI method, again passing the beginning and ending values, the input, which would be the declose double array that we built, the interval that we're using in our for loop, the 2 structures that are used by ta-lib, and finally the output array, which is named RSI, followed by the typical realignment, because every interval will, the zeroth index will point to a different day value, so we realign everything so everything lines up exactly the same, especially for the date array that we're using. We build our 2 training and testing instance files. In this case, we're using a string writer. We add the header that we built above, you saw that, and then we simply loop through the output array, and if everything's before 2018, then it will go out to the training attribute or training instance file, and everything else will go out to the test instance file. Again, we write out the close and the RSI for that day, and taking the day close and comparing it with what's ahead in 5 days, again smoothed out, we either get a buy or a sell indicator. Building the instances, building the random forest classifier and passing it the training instance. We build our test instance and then pass it to the evaluator. One other thing that I've added was we test the output from the evaluation for a non-numeric possible value, not a number, because since we're only using 2 classification attributes, if all of the results end up in the first possible classification, and the second possible classification is 0, and then the weighted functions simply do a divide. Would be just dividing the two possible values, and if the second value is 0, then we'll get a 0 divide error. Weka obviously catches it and then just throws in not a numeric possible value into the resultant value. So we'll just skip over those. We output the interval and a weighted precision and the weighted F measure or F score. And then we simply loop. We just do that and then we run it. And we open up the console. So here, there's the interval and the weighted measure and F score. Be nice to be able to get a value above 0.70, but I don't see it happening, and we're already starting to degrade here. So this one goes up to 25. I'm going to stop this here, but later on at the end of the video I will compare the output from all 4 programs. The second program uses all nominal or string attribute values. It's pretty much like the first program we just saw. The big difference is this attribute now, RSI, has 4 nominal values: a below break, below 50, above 50, and above break. And those break values actually are the overbought, oversold values that is recommended in the literature to be 30 and 70. This program will iterate or loop over values between 55 and 55 and 95, yes. And the value will be broken to step down by a steps of 1. So everything else is the same. We'll just jump down to see how the attributes are built. Again, let me just show you the for loop. The for loop has I call it a breakpoint. And it'll go from 45 down to 5, and we'll iterate by steps of 1. And it will test the RSI value. And if it's less than the breakpoint value, then it just adds the attribute below break. If it's less than 50, it adds below 50. If it's between 50 and the breakpoint, it'll be above 50. And if it's above the breakpoint, then the attribute value will be above break. Everything else is exactly the same. And we will run this. This will take a little longer because of the loop for the breakpoint, and also because of this, the test for not a numeric happens a lot in this situation. Again, I will save the output for this and run a comparison at the end with the other 3 programs. On to the third program, where we take the first program and add a new numeric attribute to it, another RSI value. So in this one I call the original RSI attribute RSI fast and the new one RSI slow. Everything's pretty much the same. We do the fast interval from 2 through 10. And the slow interval from just above the fast through 25. And in the output, we simply output the RSI fast and RSI slow for that given day, along with the closing price, and comparing the smoothed out moving average with the current closing price. Let's run this here. And this here is the fast, and this is the slow, and then this is the weighted precision and the weighted F-score. And when this is done, we'll compare it with the other three programs. On to the final program, with a similar to the second program, which we used nominal values for testing against the 3070 breakpoint. In our case, we iterate over values greater than those, and but this one we add a second one. But like the third one, we add a fast and slow attributes to the testing. Everything else is exactly the same. The fast goes from 2 through 10, and the slow goes from the fast plus 2 up to 25. Kick out the fast attribute, and we kick out the slow attribute. And since it's an ARF file, don't forget to put the comma in there. Everything else looks pretty good. And let's run it. It's a little faster. And again, once the program's done, we'll compare all four outputs. Okay, let's do a comparison of the four different programs. The first one was the single, or the numeric attributes of the current price and the current RSI for the day. And we sorted it on average weight precision and weighted F measure or F score, and you can see that we're only getting at about a 50% weighted precision at the lower end of the intervals. As you go up higher, they seem to get worse. On to the double numeric, where we used a fast and a slow. As you can see, again, this is sorted on average weighted precision and weighted F-score. Our average weighted precision and F-score got worse. So if you're going to do numerics, you might as well just stick to one RSI interval. Over into the nominals, where we tested it over various breakpoints or overbought, oversold values. Again, sorted on weighted precision and F-score. If you used an overbought, oversold value around 10 and 90 and an interval of 6 or 7, you would get a reasonably good weighted precision of 76%. The F-score there is not all that great at 48. Finally, on to where we used a fast and a slow nominal values. The best overbought, oversold value breakpoint would somewhere around 32 and 68. Pretty fast RSI interval first, and the slow interval up in the lower 20s. Reasonably a better average weighted precision and a better average weighted F-score. Okay, so that's it for RSI. The next video, I believe I will do an ensemble of a combination of several different statistical tools, such as multiple moving averages, along with MACD, RSI, maybe Wilder's ultimate oscillator, and things like that. All right, or Williams. I guess Williams wrote the ultimate oscillator. We'll see. It'll be out in about a month. Until then, if you like what you see, press the like button and pass it along to everybody else that you know that would like this kind of stuff. Thanks.